Hi guys, let's get into chapter halogen derivatives and chirality in halogen derivatives. So this is CH4 methane with tetrahedral structure. This is carbon to which are attached 4 hydrogen atoms. Alright, and these are the bonds. And the bond angle we know is 109 degree. Alright, approximately 109 degree and tetrahedral structure. Okay, alright. Keeping this in mind, let's progress now. Now, whenever we are talking in terms of Fisher's projection, now if the molecule if I represent it like this, for H attached this way, alright, then what do we assume? We assume in case of Fisher's projection, we assume that one which is horizontal is above the plane. Now this itself, whenever it is bold like this, that itself means these are above the plane. Alright, fluorine and bromine, they are both above the plane like this. Alright, okay. And when it is like this, dashed, this itself means it is below the plane. So Fisher's projection, what do we carry with us? We carry that whenever it is horizontal, it is above the plane, and whenever it is vertical, it is below the plane. Alright. So now let's come to Wedge formula. Now in case of Wedge formula, what happens is all those structures, now see in Wedge formula this is valid. Now, okay, let me put it this way. Yeah, now let me take it this way. Now assume that these two are in plane, right? Cl and fluor F. Cl and F are in plane. So what do you find this? Br is above the plane, alright, and I is below the plane. So if I check out this, if I hold it this way, now let me put it this way, right? Now see, this is in plane, Cl and F in plane, alright. Now Br above the plane, and I below the plane. I hope Wedge is clear. So what's the difference between Wedge formula and Fisher's projection formula? In case of Fisher's projection formula, here we find that whenever it is horizontal, it is above the plane, assumed to be above the plane, and whenever it is vertical, it is assumed to be below the plane. Whereas in this case, I just now showed you how the structure, all two of them are in plane, and one is above the plane, one is below the plane, which I showed right now. Okay, so and that's about Fisher projection formula and Wedge formula. Alright, now when we are finding here also, you are finding all 4 groups attached to carbon are different. Now whenever such thing is there, we call it as chiral molecule or optically active molecule. Chiral, and we represent it by asterisk. We put that asterisk very close to carbon. Alright, so let me pick up this one. Now this carbon has got Cl, F, Br, I, 4 different groups attached. So this is a chiral molecule. Alright. Now, if I place a mirror in front of it, we find that it has a mirror image. Now, if I pick up this and try to overlap over this, it won't, right? Because you are seeing here. If I overlap and keep, on bromine would come F, and on F would come Br over here. So won't overlap, though these two overlap. Alright. So these are called as optical isomers. So these are called as optical isomers. This is a chiral compound. This also is a chiral compound. This is the mirror image of this. So these are both called as optical compound. Now what it is, I would be explaining it later on over here. Now whenever you have got optical compounds like this, now mirror image of each other, you have got to understand one is R, the other is S. If one is R, the other has to be S. If one is D, the other has to be L. One is plus, the other has to be minus. One is capital D, other has to be capital L. Alright, so these are the things which we have got to keep in mind. Alright, so now what are those? Let us understand one by one.